Welcome to the 2026 Detroit Auto Show. When I came here, I expected to see something like that, but I did not expect to see something like this. This is a world debut of the next generation of the U.S. Army Abrams M1E3 main battle tank. And I'm not a tank expert, but I have one here. Alex is going to walk us around this tank and kind of tell us as many specifications as we can possibly eke out. And there's several goals with this tank. Make it a little bit more lightweight, make it a little bit more sustainable by using diesel hybrid electric. Yes, it's a hybrid electric powertrain, but using commercial components, a Caterpillar engine that might be in a semi-truck or a construction vehicle near you. That's going to power this tank, and it's going to be also very high-tech with Formula One racing seat and steering yoke to operate it. So let's go and learn everything about it right now. Alex, nice to meet you.
Nice to meet you.
Can you please introduce yourself just for the audience?
Absolutely. Hey, good afternoon. I'm Alex Miller. I'm the Chief Technology Officer for the United States Army.
Sweet. And we're here at the 2026 Detroit Auto Show.
We are.
But we're kind of in the basement level because you're introducing something big and heavy.
Because we have a tank.
And it probably can't go upstairs, can it?
It couldn't. We actually worked with the Detroit Auto Show. We found out that the bracing for the stage upstairs couldn't handle the tank. It could, because this is much lighter than the standard Abrams, but they didn't want to stress it, and I'm perfectly acceptable.
Okay, that's fine. But the exciting part is that this is kind of this is a concept vehicle still, right?
Yes.
But it's kind of showcasing the next generation of the tank technology. And Abrams, is that the largest tank platform?
So that is the family of tanks. So when you look at an M1 main battle tank in the U.S., that's the Abrams. This is
Correct.
The M1E3, and we kept that moniker. Normally, we would name the next variant of a tank another alpha numeric, so it'd be the M1A3. But we kept this one the M1E3 because we want to do something different. So, like you said, this is a concept car, but like concept cars, this can drive. So we drove this in here today. We drove it through one of the support doors.
Okay.
It is a real main battle tank. It drives, it can shoot. We're going to take it to its safety certification, and we have a term called gunnery, which is where we take it to the range and we let soldiers and teams shoot it. We're going to do that here starting at the end of the month, at the end of January. This is the real prototype of the next generation of tank.
All right, well, let's walk around this way really quick. But also tell me, please, what need are you trying to solve? Like, why do the next generation?
That's a good question. We know that our Army has to be ready to go anywhere on Earth all the time. So just for those who might not understand, everybody has seen the United States Army during the Global War on Terror, but your Army is also, we have what's called the Global Response Force. So when something happens anywhere in the world, the Army gets the call. We have the Immediate Response Force. We have the Homeland Defense Brigade. So the soldiers that are at the southern border, those are United States Army soldiers. We also do all of the homeland support. So when hurricanes hit or when national disasters hit, those are soldiers deploying. So we have to be able to go anywhere in the world to do every mission every day, which means we know that we have to be able to move across bridges in any part of the world. We have to be able to move across terrain in any part of the world. So this is really about how do we make the main battle tank, the M1, which is the best tank in the world and has been for almost 60 years. How do we continue that legacy with something that is lighter, which maintains its lethality and can take advantage of all of the technology that's coming online today? So if you look, you'll see a bunch of interesting features. So you'll see this microphone that can pick up drones if we need to. So we're learning from Ukraine. We have all of the lighting features and these cameras. So just like you would have with a pickup truck today.
In my F-150?
Exactly. So you have 360-degree view.
Yeah.
And there's a backup cam, right? We finally figured out how to do that.
You got to do it.
But if you look all around, you'll see cameras so that the crew that's inside the hull, they can see around them all the time.
So right there on the top of the turret, there's a camera and of course antennas, and then there are weapon systems mounted on top, and there's one moving right there, as you could see still. So there's cameras I'm finding all the way around this vehicle. So that's very important because I don't see any windows or slits for operator to actually look outside of the tank. But the camera systems and the screens inside will let the operator and the driver understand what's around them. And of course, there could be many other sensors. But I think the most important thing is that this tank is kind of interconnected with the rest of the battlefield, because this is not the only vehicle that's fighting in a fight. And when they were describing this, it has to be interconnected and it has to send and receive very precise messages, because you don't want to overwhelm the entire network with information, but you want to communicate and connect to the drone systems and other robotics elements of the battlefield, and also humans, of course, and make sure you could work as a team instead of working as one vehicle.
It's not just strapping a camera on, it's the entire tank has a digital backbone. It's plumbed so that we can plug in anything. So you see all the weapon systems that are up top. We just brought those for the demonstration, but we could plug in, so we have a Javelin up there, we have a cannon, we have a 7.62 weapon, but if we needed to put counter-drone directed energy or counter-drone lasers or counter-drone machine guns, we could do that as well. If we wanted to put extra armor or camouflage or extra sensors, we could do that too. So this is really about how do we make sure that the Abrams remains the most lethal thing in the world, while also taking advantage of all the robotics, all of the drones, all of the counter-drone technology that's available right now.
Forgive me, I don't know a lot about this, but so the overall size of it remains the same, right?
Roughly equivalent, yes.
But you had many different goals, like making it for the new age, kind of, right?
New age.
But also utilizing some previous parts, like the main gun, right? In the presentation, you guys were talking about this.
Absolutely. So what you're seeing on here is the 120 millimeter smoothbore. It's the most lethal direct fire. So what that means is you see the enemy, you shoot the enemy weapon system in the world. It is perfectly acceptable. We'll keep that. But it's also about how do I, instead of just the manual loading that happened in the last century, how do we do it faster? So there's an auto loader in there. How do we pair that so that this tank, which because it's got a digital backbone and it's run by software, how do we pair that so we might have a semi-autonomous tank or a fully autonomous tank? And then how do we tie all this together? Because right now in the older Abrams that are fielded, you have two joysticks that look like an Atari game from the 80s. So this one actually has a how do you take something like an F1 racing steering wheel,
almost like a yoke, so to speak,
exactly,
with a lot of different controls,
and tie all the features to it, because our soldiers, they can handle the cognitive load of having everything mapped. So if they need to control a robot, fire the main gun, fire a secondary weapon, control a camera, control a UAV, control a robot, all of this is mapped, and now this is available to them.
And operate the tank itself.
And operate the tank itself. Inside the safety of the tank.
That's very smart. And so I understand lightweighting was one concern, and I want to hit powertrain a little bit later. But tell me about a little bit the goal of lightweighting.
Sure. So the again, M1 Abrams is the best tank in the world. It's also a big girl. So coming off the line at over 70 tons, and then when we put all of the active protection and additional armor, some of them were pushing over 80, and then when you add extra ammo, you're getting to the upper 80 ton. What we wanted to do was cut that by 20 to 30%. So our goal with this was no more than 60 tons. And we want to trend down. So if you look along the side, you see all the paneling. You can start to remove some of those to even cut the weight more.
Like the track protection on the side,
like the track protection. Okay. So if we go into an environment where maybe the enemy doesn't have a main battle tank or the threats are a little bit different, we can drop some of that weight. The other thing is, we're at a point now where we can work with companies and do and leverage the current state of technology to do new chemistries for the metal, new metallurgical processes. So maybe we can drop some of the weight there while having the same level of protection.
But also, you talked about maybe because it now has a smaller crew, right?
It's a 3-man crew, yes.
So, and that allows you some more freedoms, right? To maybe make the turret a little bit smaller and realign the armor, right? And
pull weight off. And really, the reason that the Abrams is so heavy is because, it's two reasons, both physics reasons. One, to fire the 120 millimeter smoothbore, it has to have enough weight so it doesn't flip over. So that's one physics reason. The other one is we want to protect the humans inside. So it's got armor so that if it took a main round from another main battle tank, it would survive. So if we make the crew smaller and we put them in the front compartment and we focus where the armor is, even if the tail end of this took a main battle tank round, and by some stretch of the imagination there was a catastrophic kill, the crew is still protected. They can manually release the hatch. They can get out. They can survive. We can keep our soldiers alive.
Yeah, that makes a lot of sense.
Yeah, and there's some other cool things when you start thinking about those trade-offs. You get to things like different powertrains, things like different engines. The goal here is, as much as the weight reduction, it was also what's the logistics. So this tank can go either twice the same range on the same gas or 50% less fuel consumption if you need to. So being able to reduce more efficiencies out of the engine, more efficiencies out of the powertrain, more efficiency out of the power pack gets you a lot of different trade-offs.
No, that's a great segue, because can we look at the engine?
Absolutely.
And it's also a hybrid, right?
It is.
Okay.
And
so let's take a look at this Caterpillar engine.
So normally, traditionally, what would happen is the Army would design something from scratch, and we would ask for a custom engine, we would ask for a custom power plant. What we said instead is, industry, here's our objective. We need to move this main battle tank. What can you do? And Caterpillar came up and said, hey, we make big trucks, we make engines to power those big trucks. I think we can pull this together. So you get this hybrid electric engine with Caterpillar, and then the transmission with SAPA, to actually bring this all together into something that we can repair anywhere on the world. One of the really cool things is right now, if an Abrams has to go, we call it into depot, if it has to go to repair, you got to bring it home. Like it's very hard. You got to bring it to a major base. With this, if it breaks down anywhere in the world, call Caterpillar, and we can get that anywhere in the world.
Yeah, and those engines are available in other commercial vehicles,
exactly.
Right?
So
potentially.
So commercializing the supply chain for our vehicles allows us to actually take advantage of the supply chain.
Now, tell me about that.
So the SAPA transmission and the power distribution. So it's the same concept, same as the power plant. How do you take a transmission that can make the provide the multiple tens of thousands of horsepower that the tank needs to get up and go, and you're not waiting for the diesel engine to spool up, you're not waiting for it to get warm, and you can deliver power immediately when the soldiers need to drive. Because the key thing here is, and this will evolve over time, SAPA was the provider bringing that to us. The main thing is mobility is survivability on the modern battlefield. If you're sitting waiting for things to happen, you're not going to survive. So that's what you're seeing, all these modern transmission.
Can you give me an idea of what's happening? Is that the output shaft that connects to the engine?
It is. Power distribution. So it's correct? One piece. So we put it all together, the crank from the engine, and it goes into the back of the. That's why the back sticks out. The whole sticks out.
So this is kind of closer to the rear.
Correct.
Okay, and then is that the output shaft?
It is for the main axle that's sitting right there
in the back.
As you see, if you look at
this right here, yeah.
If you look at the back of the tank, you see the rear axles up top to drive the tracks. This is the output there.
Okay. So, and then the engine is kind of here and right just in front of it.
Yep.
Yeah. So you're saying it's really, I heard the term during your presentation, it's kind of a performance hybrid. Somebody mentioned the Corvette ZR1X, where the electricity and combustion combine together to make performance.
Exactly. So
or efficiency also, potentially.
So it's both. So as soon as you let off, use a colloquial term, as soon as you let off the gas, all that power is available still to either drive it or slow it, or to drive the rest of the systems, so that in the event that you want to be in something like, we have a term called silent watch, where maybe the engine's no longer running, but you have the power available still, so that you can run all of the sensors and the weapon systems and the cameras and all those things. And if you still need to shoot, you can, and then you can immediately turn the tank back on and start driving to get out of a fight if you need to.
Now let's take a look at the rear of this tank. This is really where the powertrain resides, and that's how it's driven. So in this gigantic area back here behind the turret, that's where you will find that Caterpillar engine, and of course that big massive transmission that incorporates an electric motor or motors, and of course batteries will be housed somewhere in here. And look, it has a hitch. Maybe we can do an eye-gauntlet towing test. There's a pintle hitch right here that this tank will probably, it's literal tank. So here, in our business, when we talk about pickup trucks and semis, we say something, oh, that truck looks like a tank, or it works like a tank. Well, this thing is a tank, and it will go anywhere. And some of their specs that they were trying to hit, they want, when it leaves the factory, they want this tank to weigh about 60 tons versus 70 tons plus where it used to be. So they have a 20 to 30% weight reduction goal, which is also great because it means it's more efficient. It's easier to refuel because you need less fuel potentially, and moving fuel, like some of the colonels and generals were talking about, moving fuel on the battlefield is difficult and costly. So if you can make this more efficient, and they're talking about making it 50% more efficient, and also doing it fast. So according to the team over there, and Alex and the rest of the team, they were able to move within months and years, not decades, to redesign this tank and make it way cooler. So I'm assuming there's also a battery of some kind to help out the electric components.
There will be, and that'll also be commercial. We haven't really settled on what that'll look like, but
okay.
We were having a conversation on different battery chemistries in terms of lithium ions, probably not the right chemistry because of the size and weight. Maybe we'll look at something like lithium phosphate, but again, it's a weight and it's a power density to size conversation that we have to figure out. And what I'm super excited about is we don't have to learn that alone. And over time, as industry solves those problems, we will just be able to adopt them.
And is that why you're here at the Detroit Auto Show?
That's exactly
because
right.
I mean, we're looking at Ford Mustangs and
looking at awesome cars.
Yes.
So two reasons. One, absolutely, we want to make sure that industry knows.
Let's turn back here.
We want to make sure that industry knows we want to adopt the technology quickly, but there's another sort of less technical, more philosophical. So. Motor City, Detroit, helped win World War II. Like a lot of capability was built here. The first tanks were built here.
The Willys Jeep, for example.
The Willys Jeep, the Chrysler Defense was built, first designed for the Abrams. What better place to unveil this than the team that actually built it? And that is why we're here at the Detroit Auto Show.
Well, thank you very much for your time.
Thanks for being here.
I'm trying to learn as much as I can, so I really appreciate it.
Yeah, absolutely. Thank you for being here.
Thanks. This is still a concept tank, and the production version may be still a couple years or several years in the future. And during their presentation, they were saying that people who will operate the crew of 3 inside of this tank may not be recruited yet. These are young people. So I think it's a really cool idea that they're having the interface using kind of a yoke steering wheel with a lot of different controls, very similar maybe to a video game or a simulator. So I think that's a really interesting technology. But I think they're hitting a lot of I like a lot what they're doing with it. They're making it more efficient. If I lost 20% of my weight, I would be a lot more efficient myself. So they're reducing weight, using commercial components, potentially driving down cost, which is really important on a vehicle like this, making the people inside, our U.S. Army soldiers, more safe. And all those things are just, there's a lot of positives just are rolling kind of all the way. So this is really interesting. Maybe we need to start TFL Tank and start reviewing tanks. Let me know what you think in the comments below, and check out oldtfl.com for everything automotive and maybe even tank reviews coming up soon.